All right, let's continue where we left off. Let's look at number 7. All right, so what does x need to be so the natural log of that number is -3? Well, I'm going to change this to an exponential equation. And remember, anytime you see natural log, if you want, it might help you write in the base of e. I know it helps me. All right, let's change it to an exponential equation. So e to the -3 equals x. Just find this answer on the calculator and you're done. So x equals, rounding to 3 decimal places, we're going to have 0.050. Well, let's take a look at problem number 8. All right, so our approach to solve this equation, notice that you have one log term on both sides of the equal sign, and that's all you have. You don't have anything else. You don't have multiple log terms. You just have one log base 5 on each side of the equation. Well, those drop out. So if log base 5 is on both sides of the equation and that's all you have, dropping them out, that tells us that 3x plus 2 must equal -x. All right, let's solve this equation. It's not quadratic, so I'm going to add the x to the other side, and that's going to give me 4x plus 2 equals 0. Subtract the 2, dividing both sides by 4, x equals -1/2. And for some later problem that's going to come up, it might be worth noting that when you look back up here, you can't have a negative value in this expression right here. And we saw that in a previous problem too, but that's okay because when x is -1/2, the opposite of -1/2 becomes +1/2. Remember, this argument always has to be a positive number. Okay, and the result of taking the opposite of this -x value would give us that positive number. So we're good there. But I know in a problem coming up, we're going to have to check, and I think it actually is just this next problem. All right, we're not done over here. Let's finish writing the rest of the problem. All right, here's our equation. This is what we have to solve. If you're thinking that we're going to just drop all the ln's out, the natural logs, and we can't do that unless we have just one expression on each side of the equation. And over here we just have one log expression, but over here we have 2 of them. So that strategy of dropping out the logs doesn't work unless you have just one log equation on both sides of the equation. So what do? Well, we can make one log equation over here on this side of the equation by thinking about our log properties. Because I see a plus, I'm thinking of the product property. If both of these expressions have the same natural log or the same log and I have a plus between them, I can condense these two into one ln expression. All right, taking these, I'm going to put a bracket here. Think of that as one factor and that is your second factor. And I'm going to collapse this. So I'm going to have x minus 1 as my first factor times x plus 1 as my second factor. The log properties allow us to condense this. So the ln of x minus 1 plus the ln of x plus 1, I could check my work by going backwards, and that works. Okay. Now can I drop out the ln's? I sure can, because I only have one ln expression on each side of the equation. So x plus 5 must equal this product right here. All right, now it just becomes algebra. Let's FOIL these together, zero one side out, and then use our quadratic techniques of solving. All right, you can FOIL over here, but when you FOIL, it's just going to give you x squared minus 1 because one binomial is plus and one's minus. Okay, I have a quadratic. I'm going to zero out the left side. So subtract an x to the right side. So x squared minus x. Subtract a 5 to the already negative 1, and that becomes minus 6. I'm going to trade sides. All right, I'll avoid the quadratic formula because I can factor. Factors a negative 6 that add to negative 1 would be minus 3 and plus 2. Before I box these, I want to just draw your attention to this solution right here, negative 2. Go back to the original equation, replacing every x with negative 2. Well, if x is negative 2, the result here is positive 3. That's good to go. But if I replace this x with negative 2, then negative 2 minus 1 would be negative 3, and the natural log of a negative number doesn't exist. So we say that this solution is extraneous. Check the 3. By replacing this x with 3, we get a positive number. That's good. By replacing this x with 3, we get a positive number. That's good. And then this would also be positive. So the only solution through all that work is x equals 3. All right, let's solve this log equation. And again, I can't drop the logs out because I don't have one log on each side of the equation. If I added this term right here to the right side of the equation, I'd still have a half plus this term. And that doesn't fit the description of being able to drop out the logs because that 1/2 is in the way. All right, so what's my option? Well, like the previous problem, you might want to think about properties. Maybe I can collapse this. I see the minus. I see the same base of 4. So I'm going to lose one of the log base 4s, and I'm going to create a fraction. So with a minus, I'm thinking quotient property, put the x, which comes first on top, and put the x minus 1 on the bottom. Does that help by collapsing to one log expression? Sure, because now I can change it to an exponential equation. So 4 raised to the 1/2 power equals x over x minus 1. I know what 4 to the 1/2 power is. It's the square root of 4. 1/2 means square root, so square root of 4 gives 2. X over x minus 1. Okay, how do you solve this equation? I think the easiest way is put 2 over 1 and do cross multiply. Just be careful, you got to distribute the 2 with the x and the minus 1. So the result would be 2x minus 2 equals the other product of x. All right, so let's solve this equation. So I'm going to subtract an x to the 2x. So that's going to give me just 1x minus 2. I've zeroed out the right side, but I'm going to add a 2 to the right side. So my solution is x equals 2. And just double check, plug 2 back in for that x, that's good, that's positive. Plug 2 in for that x, that's good, that's positive. Okay, so x equals 2 is a valid solution. Okay, 3 more to go. Woohoo! What are we on, 11? If you know what to do, I encourage you to stop the video, attempt this problem on your own, because at some point we're going to have to move away from our notes and understand the processes and tackle these problems on our own. So if you want to stop the video because you think you know what to do, I encourage you to do so and then come back and check. Okay, so for me, I'm going to isolate the natural log of 3x. I'm going to add a 2 to the other side. That seems like an obvious thing to do. I'm going to divide both sides by 2. I can't drop out natural logs because I don't have a natural log on both sides of the equation, so I guess the next thing for me to do is change it to an exponential equation. So I'm going to divide both sides by 3 to isolate x. I'll trade sides. Go to your calculator, build your fraction template. In the numerator, e to the 19 divided by 2 power, divide by 3. See, I have that answer somewhere. Oh, it's super large. You might want to double check me on that one. That just seems uncomfortable. 4,453.242. 2 more.
Are you finished?
Okay, so this is 7 times log base 4 of 0.6x equals 12. Stop the video, attempt it on your own, come back and check. Self-assess. I'm going to divide the 7 to the other side. And I wonder if some of you might be thinking you could take the 7 and make it a power. Well, it's just not going to get you anywhere if you did that. I mean, it's correct to do it mathematically by the power property. But let's just go ahead and get rid of it by dividing it into the 12. I've isolated the log expression, so let's go ahead and change it to an exponential. Four raised to the 12/7 power equals 0.6x. All I have to do to solve for x is divide both sides by 0.6. All calculator work. Alpha y equals, build your fraction template, build another fraction template for that exponent. Round to 3 decimals. 17.945. Hoping you got that on your own and you're just checking. Last one. All right, you might still have room on your paper to do 13 across the side, but I just needed to start a new sheet of paper. I wasn't sure how much room I was going to need for this problem. All right, last problem, 13. Okay, I think I'm going to write in the understood base of e, change to an exponential, and go from there. I'm not going to FOIL this. I want to extract the square roots. Okay, this result is e. if I bring in the square root, an even root, not an odd root, I need to bring out my radicand in the absolute value. And I'm going to go ahead and trade sides. Okay. I didn't bring out an absolute value here because e is a number. It's only when you have a variable. I'm going to remove the absolute value. When I do that, I make the adjustment to positive negative e. I'll subtract a 1 to both sides. That makes it -1 plus or minus e. I'll write my solutions out. -1 minus e, comma, -1, plus e. Okay, I might want to real quickly check to make sure that neither one of those x values here, when replaced in for this x, would give the result of a negative number. And you know what? No matter what you put in for x, even if you get a negative inside these parentheses, you're going to square it. It becomes positive. So both these solutions should work. You can change them to decimals if you want, but I'm just going to leave them as is. They're exact. Woo, done! At least for now, solving log and exponential equations.